Let's look at a little bit more complex vertex shaders. Here we have added a few extra lines of code to our original simple shader program. We still have the input vertex position as an in variable, but we have additionally defined an out variable color and a uniform variable theta. Vertex shader can produce output for the rasterizer and fragment shader further down the pipeline. It can basically perform per vertex calculations to find out how light should interact with material properties to produce an output color. The uniform variables can also be defined inside a vertex shader. We'll have details on this in later slides. Finally, we assign the vertex positions to the inbuilt GL position variable. Here is an example of a complete vertex shader program that produces wave motion. We have the vertex position coming as an in variable from the application program, and then we define three uniform variables. The first two are related to the frequencies in the X and Z direction, and the third one is the height scale of the wave. We start with the original vertex position, assign it to the variable t, and alter its y value based on this formula, which is the sum of the initial y value plus two sine functions. The sine functions get multiplied with the height scale and then calculate the sine value of time plus the x frequency multiplied with the x value of the position and the z frequency multiplied with the z position of the vertex. The final calculated value is then reassigned to the inbuilt variable GL position. To see the complete application program, see wave.cpp and wave2.cpp in the extras directory in your lab. Here is another example where we have a little bit more complex vertex shader program. It's a particle system and we have multiple uniform variables defined. Some of them are mat4, which is a 4x4 matrix, and it's basically a model view projection matrix. And we have float variables, gravity, mass, and time, and we also have a velocity variable. Note that all three values of the position of the particle are being affected, and the final value of the particle is multiplied with the projection matrix to produce the final position and store it in GL position, which is the inbuilt variable. Vertex shader programs written for Linux or Windows are different from Mac. This slide shows a side-by-side comparison. Note that the qualifiers attribute and varying are still being used for Mac, whereas in Windows and Linux they have been replaced with in and out qualifiers.